A crystal lattice is an infinite periodic array of points in space. It shows how the constant particles are arranged at different sites in three-dimensional space. A crystal lattice is made up of a set of parallel and equidistant planes passing through the lattice points. These planes are parallel to the crystal faces and are called lattice planes. The lattice planes intersect the atoms of a unit cell and can be constructed in many ways as shown in the figure. The distance between each of these planes is called the d-spacing. Let OX, OY and OZ represent the three crystallographic axes. Let ABC be a unit plane. The unit intercept along the x-axis is A. Along y-axis, the unit intercept is B. And along z-axis, let the unit intercept be equal to C. Now consider a lattice plane LMN in a crystal. The faces of the complete crystal will be parallel to this plane. This plane has the intercepts OL, OM and ON. OL is along the x-axis, OM along y-axis and ON along z-axis. OL is at a distance 2A, OM is at a distance 2B and ON is at a distance 3C. The intercepts are in the ratio 2A is to 2B is to 3C. Here, the coefficients of A, B and C are 2, 2 and 3 and they are whole numbers. The coefficients of A, B and C, that is 2, 2 and 3, are called the V's indices of the plane. Thus, the ratio of intercepts of any crystal plane on the crystallographic axis is given by LA is to MB is to NC. Here, A, B and C are the unit intercepts along the crystallographic axis. L, M and N are rational numbers. The coefficients L, M and N are called the V's indices or V's coefficients. Please note that V's indices can be infinity. It can also have fractional or whole number values. The orientation of a set of planes of a lattice can also be specified by a set of integers h, k and l. These are used to describe a given plane in a crystal, and these are called the Miller indices. Miller indices are preferred since it is much more convenient to use than V's indices. Miller indices of a face of a crystal are inversely proportional to the intercepts of that face on various axes. Miller indices are a set of intercepts which are the reciprocals of its V's coefficients with the fractions cleared. Please note that while writing Miller indices, no comma should be used and also it should be written in brackets. These are the steps to find the Miller indices of a plane. First, write down the V's indices of the plane. Then take the reciprocals. If it is not a whole number, multiply with a common factor and convert to simple whole numbers. Then enclose within brackets without any commas. You will get the Miller indices of the plane. In the example that we have seen earlier, the V's indices were 2, 2 and 3. The reciprocals are 1 by 2, 1 by 2 and 1 by 3. Since these are fractions, we are going to multiply by a common factor. Here, the common factor will be 6. So multiply each of these fractions with 6 and you will get 3, 3 and 2 as the Miller indices. We have to put it in brackets without any commas. In one of the earlier videos, the laws of crystallography was mentioned. You have studied the first law, the law of constancy of interfacial angles. Now let's study another law of crystallography, the law of rational indices. The law states that the intercepts of any plane of a crystal along the crystallographic axis are either equal to the unit intercepts or some simple multiples of them. This means that the ratio of intercepts of any plane in the crystal is given by LA is to MB is to NC, where A, B and C are the unit intercepts along the crystallographic axis and L, M and N are rational numbers, and these L, M and N are called the V's indices of the plane. Now let's consider a plane designated as infinity A is to 2B is to C. Let's calculate the Miller indices of this plane. Hope you remember the steps to be followed to find out the Miller indices. Let's see the steps now. First, write down the V's indices. Then take the reciprocals. Multiply with a common factor. You will get whole numbers. Put these whole numbers in a parenthesis without any commas. You will get the Miller indices. So here the V's indices are infinity, 2 and 1 as given in the question. The reciprocals are 1 by infinity, 1 by 2 and 1 by 1. 1 by infinity is 0 and 1 by 1 is 1. So 0, 1 by 2 and 1. Since there is a fraction here, we are going to multiply it with a common factor. Here the common factor can be 2. So 0 into 2, 1 by 2 into 2 and 1 into 2. So you will get 0, 1 and 2. So the Miller indices of this plane is 0, 1 and 2.